Welcome back. In the previous video, we discussed quality assurance activities in waterfall projects. In this video, we will resume our discussion and we'll discuss the remaining models such as prototyping model, incremental model, the spiral model, and agile development methods. Okay, here we will discuss the prototyping model. The prototyping model replaces some of the parts of the waterfall model with an evolutionary and iterative process. When applying the prototyping methodology, the intended users of the system are involved in the process to comment on the various versions of the software prototypes that are being used by the that are being actually prepared by the development teams. So in response to the customers and end users comments, the developers crack the prototype and they actually adjust the customer's feedback and improve the product or like that specific prototype, and in fact add parts to the system on the way to presenting the next generation of the software for user evaluation. So this process is repeated till the prototyping goal is achieved or the software system is completed. So prototyping can improve the quality of requirements and specifications provided to developers, because in this approach the users or customers, they are in close contact with the development teams. Therefore it is assumed that the requirements, they have been clarified. There is no ambiguity in the requirements. Similarly, the requirements may be complete. Therefore no change requests, they might arise or originate in the later stages of the project. Of course, if such requests, they arise in the later stages, then they can increase the cost of the project exponentially, and there are also the chances of degradation of the architecture of the system, because most of the product is complete and we have to accommodate the new change. So in this case, therefore, if the architecture of the system is degraded, the quality might be compromised. So prototyping requires user involvement and allows the users to see and interact with a prototype, allowing them to provide better and more complete feedback and specifications. Incremental model. The incremental model actually proposes to develop the system in small increments, and in fact in each increment part of the functionality of the system that is added, and in fact in each iteration some part of the functionality is added, and which all together finally form the complete system. So each iteration in the incremental model that is completed in a waterfall like style. That is, in each iteration of this model we have all the activities, or we may follow all the activities that we follow in waterfall model. So the result of each iteration is in fact integrated with the already existing systems, are the already developed increments. So the focus of an iteration may be on usually developing new functionality, but sometimes the focus might be on refinement of an existing implemented procedure or a methodology, or improvement of methodology, or like sometimes architectural consolidation might be a focus of an increment. Then quality assurance in incremental model. As we discussed here, that the overall process consists of several increments or iterations. So with each of them like following more or less the same substages as we saw in case of waterfall model. However, it is important to note that at the end of each iteration, the newly developed parts of the system need to be integrated with the existing or the already developed components of the increments. Therefore, integration testing is very important here to make sure that different parts can interoperate correctly to fulfill the required functionalities correctly together. Of course, the other activities that we had discussed in case of waterfall, like they of course they are also important and they will be applied at their designated stages. But here, since the products are like or the like in the product is being developed in increment, so integration of those increments is very important, that may affect the quality of the system in the future. Then the next model we'll see here is spiral model. The spiral model introduces an improved approach for overseeing the development of large and complex projects with high probability of failures, or that carry lots of risks. The spiral model combines like aspects of different models. For example, waterfall model, the incremental model, and like prototyping. And it in fact like couples the iterative nature of prototyping with the controlled and like systematic aspects of waterfall model to provide or to introduce a more like risk-oriented approach. So one of the key features of these models that distinguishes it from the other models is that this is a risk-centered model that considers a risk analysis important to be performed in each spiral or each iteration. So the spiral model, in each spiral or each iteration of this model, the traditional like development activities, they may be followed. For example, traditional waterfall like activities, for example, in each iteration, the activities such as planning, risk analysis, and resolution. Similarly, engineering activities mean the core like development activities. For example, requirements analysis, design, coding, testing, and customer evaluation, etc. are performed. So each spiral includes explicit risk assessment. So the benefit of risk analysis here is that the risks at in each iteration or each spiral, they are analyzed, and if there are any risks, appropriate mitigation strategies to cope with those risks, risks are identified. As the waterfall model, it is considered a heavyweight and plan-driven methodology, and also this is highly structured in nature. The quality assurance activities performed in the spiral process are similar to those like in incremental approach. However, the minor difference is typically that it has a risk-focused approach where risk identification and analysis plays an important role. Like so, actually, the risk-centered approach leads naturally to like emphasizing more on the areas that contain high risks. That's why this model is preferred for projects that are large in size and complex in nature. Then agile development. Agile development methodologies actually emphasize on customer satisfaction and rapid delivery of the software products. So usually in these projects, the development teams they are smaller and usually they do not follow any formal structure. Similarly, an important distinction here with the conventional process models is that agile process or agile development does not emphasize on extensively producing documentation or like intermediate work products. Of course, some documentation is there, but it is not that extensive. So it emphasizes on effective communication between among all the stakeholders, and particularly it emphasizing on involving customers in the development teams. Then how quality is assured in agile projects. Post quality assurance activities here in agile, particularly testing and inspection, play even more important role than in the traditional software development processes. For example, test-driven development that is an integral part of extreme programming, and inspection in the form of two-person inspection or programmer pairs is extensively used with the purpose of writing the high quality code with minimal errors or flaws. So here we see that performing the quality assurance activities at different stages of development using any of the process model ensures a high quality product that is developed within its allocated budgets and schedules. So that's all about our discussion on life cycle models and quality assurance activities. The materials used in this video are based on our selected course books, that is Software Quality Engineering, Testing, Quality Assurance and Quantifiable Improvement by Jeff Tian, and the second book, Software Quality Assurance from Theory to Implementation by Daniel Gallen. Thank you.